Hello guys, this is 2.4. We're looking at differential equation formulas. Now in this case, in this section, we're going to learn how to find derivatives of some functions uh, with formulas, with properties as well. And this is going to save us a bunch of time on finding derivatives, and this is what you will be using for the rest of the class. Okay, so let's start with constant function. Let's say I have a function that is just some constant, let's say 5. Okay. All right. And then what we're going to do now is apply the definition. Apply the definition to find f prime. Right? So f prime of x is equal to the limit as h approaching 0 of f of x plus h minus f of x over h. Now in this case, since it's a constant function, we just have 5 minus 5 in the numerator over h, right? And that's just 0 over h, right? So that's equal to 0. Okay. And in fact, when you take derivative of any constant function, the derivative is always going to be 0. Okay. Or another way to write this is if you take the derivative, right, using d dx form of some constant c, it's always going to be equal to 0. Okay? And let's take a look at why that is. Okay? So if you look at the constant function, look at the graph, which is just a horizontal line, right? A horizontal line for the constant function. And we notice that the horizontal line has the slope of 0. That's another reason why we get the slope is equal to 0 when we're taking the derivative of a constant function. Okay, so next type of function we're going to look at is the power function. So the power function takes the form of f of x is equal to x to some power of n. Okay. Now, of course, we can apply the derivative, apply the definition of the derivative to figure out what the formula is. But here, let me give it to you first, right? So f of x is equal to x to the power of n. To find f prime of x, right? All you need to do is bring down the power n, okay? So what I mean by that is in the exponent, we have this power n. We're going to bring it down to the front, okay? And then copy the x, and the new power of x is going to be decreased by 1. Right? So instead of n, we have n minus 1. Okay? And that's the derivative formula for finding power functions. Right? So let's do a quick example. Let's say f of x is equal to x to the power of 3. Then f prime of x, you're going to bring down the 3 to the front times x and reduce the power by 1, 3 minus 1, which gives you 3x to the power of 2. Okay, let's do another one. Let's say we have f of x is equal to x to the power of pi. Then f prime of x is going to be, right, bring down the power again, same thing, right? Pi times x, and then subtract the numerator, subtract the exponent by 1. Right? So we have pi minus 1. Right? So very simple. This is the how to find derivatives of power function. Right? And this extends to polynomial as well. Okay, bring down the power, decrease the power by 1. All right, and let's do one more. What about f of x is equal to x? Right? So if it's just x, that's a linear function with x with the power of 1. Right, so let's see. To take f prime, what do we have? We have, okay, bring down the power of 1, multiply by x to the power of 1 minus 1, which is 1 times x to the power of 0. And any number to the power of 0 is 1, right? So this is actually just 1. Okay. All right, now let's take a look at the same thing, but using a slightly different notation. Let's say f of x is x to the 4th power, and we want to find the derivative d dx of x to the 4th power. I remember this differential notation. right? It's basically saying that we want to find the derivative of x to the fourth, right? That's the same thing. Bring down the power and reduce the power by 1. And we're done. Okay, very nice, very easy. So you can see that with this formula, we don't have to apply the definition to find the derivative every time. When we have a power function, we can simply follow the rule, bring down the power, decrease the power by 1. All right, next we have some rules. Let's look at the first one, the constant multiplication rule. Right. If C is a constant and f is a differentiable function, then the derivative of some constant multiplied by a function is equal to the constant multiplied by the derivative of the function. Okay, so let me give you an example of what I'm talking about here. Let's say I have a function that is 2x to the third power. Okay, so to find the derivative of 2x cubed, this is the same thing as doing 2 times the derivative of x cubed. Right? And we know how to find the derivative of x cubed, right? This part right here, bring down the power, decrease the power by 1. So what we have here is 2 times 3x squared. Right? And then you can combine the 2 and 3 by multiplying them together, right? So 2 times 3, that's 6x squared. Okay. All right, and let's try another one. Let's say I want to take the derivative of negative x. Right? So that is the same thing as taking negative 1 times the derivative of x. Right? And we know that the derivative of x is 1 from earlier, right? So this is just negative 1 times 1, which is negative 1. All right, next we have the sum and difference rule, right? When we want to take the derivative of a sum of functions or a difference of functions, you can just take the derivative separately. Okay? So let's do an example. F of x is 2x squared minus 5x. Right? So let's say I want to take the derivative of the function f of x. Okay, that is the same thing as saying we want to find the derivative of 2x squared minus 5x. Now, by the difference rule, or sum and difference rule, I can do so by taking the derivative of them term by term. So meaning I can find the derivative of 2x squared first minus the derivative of 5x. Okay, and to do so, we apply the power rule, right? Bring down the power. So bring down the 2 multiplied by the 2, we get 4x, and decrease the power by 1, we have power of 1, minus the derivative of 5x is the same thing as 5 times the derivative of x, right? Which just gives us 5x minus 5. Okay, and that's it. So in a more general sense, if you want to take the derivative of f plus g plus h, right, where f, g, and h are different functions, right, you can just take the derivative of each one of them separately, like f prime plus g prime plus h prime. Okay, very nice and simple. All right, so here we have something that's a little longer, right? We got a really long polynomial, right? 6 terms to be exactly. So let's see, what do we do when we want to take the derivative of this, right? So we're going to apply the sum and difference rule and also the constant multiplier rule to everything, right? So let me write it down. So first one, I'm just going to take the derivative of x to the power of 8 plus 12 times the derivative of x to the power of 5 minus 4 times the derivative of x to the power of 4 plus 10 times the derivative of x to the power of 3 minus 6 times the derivative of x and plus the derivative of 5. Okay, and let's see what we have in each. All right, so x to the power of 8, bring down the power, decrease the power by 1, plus 12 times, bring down the power, decrease the power by 1, minus 4 times, bring down the power, 4, decrease the power by 1, plus 10 times, x to the third power, so bring down the power, decrease the power by 1, minus 6 times, derivative of x is 1, plus derivative of 5 is 0. All right, so let's clean this up a little bit. We have ax to the 7th plus 60x to the 4th minus 16x cubed plus 30x squared minus 6. Okay? And that's it. That's how you find the derivative of this long polynomial, right? Now, this is much shorter than, let's say, if you want to find the derivative of this polynomial by the definition, right? Of course, I'm sure everyone would agree that it's going to take you a lot of time to find the derivative of this polynomial using definition. Okay, so here we have this nice rule of the power rule. All right, next we have another rule called the product rule. So the product rule is when you want to take the derivative of two functions multiplied together. Let's say f times g. Now, maybe some of you will say, oh, maybe we can just put a derivative on f and multiply by the derivative of g. Okay, this is not true. Okay, don't do this. Don't do this. Okay, f times g prime is not equal to f prime times g prime. Okay, make sure you don't do this. Okay. So here is the formula for the product rule. To find the derivative of two functions multiplied together, you have to apply this rule. Now, in this notation is a little annoying, right? So what we're going to do is I'm going to write out in terms of fg prime, right? This is equal to f times g prime plus g times f prime, which is also the same thing as f prime times g plus g prime times f, right? Because addition is commutative, it doesn't matter which one comes first. Okay, so when you have two functions multiplied together, you have to use this rule to apply to find the derivative. Okay, so let's take a look at an example. Find f prime of x if f of x is equal to 6x cubed times 7x to the 4th. Now, for the sake of practicing product rule, we're not going to multiply these two out. We're just going to keep them in this product form, right? So to apply our product rule. Okay. So before we do that, one thing I like to do with product rule is I want to identify the two functions I'm working with, right? Let's call them u and v. Right? On the right-hand side, I'm going to write down the product rule. Right? U times v prime is equal to u prime v plus v prime u. Right. So what I like to do is I like to list out u, v, and u prime and v prime before I move on even further. Right. So u is 6x cubed and v is 7x to the 4th. And let's go ahead and find the derivative of these two things. U prime is bring down the 3 multiplied by 6, so 18x squared. And v prime is 4 times 7, that's 28, x to the 3rd power. All right, so now that we have everything ready, we can go ahead and apply the product rule. Okay, so f prime of x is equal to u prime v plus v prime u. Right, and let's see what we have here. So u prime, that's 18x squared times v is 7x to the 4th plus v prime u. V prime is 28x cubed times u, which is 6x cubed. All right, and let's see what we have. You'll have 168 x to the 6th power plus 126 times x to the 6th power, which combines to give us 294 times x to the 6th power. Okay, so that's the product rule. Now remember, when you are trying to take the derivative of a product of functions, f times g, you have to apply this rule. You have to apply the product rule. Okay? And it doesn't matter if you use the notation FG or UV, right? It'll give you the same result. Or we use UV in this case because we already have F to represent the original function. So sometimes in order to avoid some confusion, I will use U and V to represent the two functions we're multiplying together when we are applying the product rule. All right, next up we have the quotient rule. Right? So the quotient rule, just like the product rule, is when you want to find the derivative of f over g. Okay? And again, this is not equal to f prime over g prime, right? Please don't do that. Even though you might be tempted to do this from time to time, but yeah, it's not the correct way of doing it. So let me go ahead and write down the correct way of doing it. F over g prime is equal to g squared in the denominator, and then f prime times g minus g prime times f. Okay, and that's the formula. This is of the easier form, and in our textbook we actually have the more formal form, which I will leave it right here for your reference. But personally, I think this form right here is a little easier to understand because it doesn't include that much notation. But you can compare both of them. They are actually the same thing. Okay? But more importantly is whether we know how to apply or not, right? So let's do this. Let's say y is x squared minus x minus 2 plus x squared plus x minus 2. Denominator is x cubed plus 6. And we want to find dy dx. Okay. And again, the same thing here. We're going to label the numerator and denominator using a different function notation, right? Let's say this is u and v again, right? So u over v prime is going to be v squared in the denominator, and then the copy of v times u prime minus u times v prime, right? So we will need u prime and v prime here as well. And just like product rule, I like to list out everything before I move on. So u is x squared plus x minus 2. V is x cubed plus 6. Right? And let's go ahead and find u prime. U prime is going to be 2x plus 1. And v prime is going to be 3x squared. Right? Notice that all I'm doing here is applying the power rule. Right? Bring down the power, decrease the power by 1. So now that we have u, v, u prime, v prime already, let's go ahead and find out what the derivative of y is. Right? So dy dx is equal to the derivative of u over v, which is, by applying the quotient rule, it's going to be v times u prime minus u times v prime all over v squared. Right? And let's just go ahead and plug in everything here. So v is x cubed plus 6 times u prime, that is 2x plus 1, minus u, that is x squared plus x minus 2 times v prime, that is 3x squared. Okay. All over v squared, so that's x cubed plus 6 quantity squared. Okay, now of course we can clean this up a little bit, right, and see what we have. So FOIL it out, we get 2x to the 4th plus x cubed plus 12x plus 6 minus 3x to the 4th plus 3x cubed minus 6x squared. Okay, and all over x cubed plus 6 quantity squared. All right, and then numerator, we can combine a lot of the things together. Let's see what we have. We have negative x to the 4th minus 2x cubed, right? Yeah, minus 2x cubed plus 6x squared plus 12x plus 6. And again, all over x cubed plus 6 quantity squared. Okay. So product rule and quotient rule, they're pretty straightforward. Just need to apply the formula, and of course you want to know how to apply the formula. And here I'm going to talk a little bit about how you can memorize the quotient rule without, actually straight up memorizing it. Right, so let's do u over v. Right. So now you have some quotient, derivative of a quotient. So usually I start with the denominator. Right. The denominator is going to have a square, and then make a copy in the numerator, multiply by the u, the derivative of u, and then minus, and the other term is just move the derivative to the other one, right? So in the first part, the derivative is on the u. Now it's going to be on v, right? So v prime times u. Okay. Even though the order of v prime and u are different, but again, multiplication is also commutative, right? So it doesn't matter the order that we write them in, right? They will be the same thing. Okay. All right. Now let's look at something that's a little more different. Let's say f of x is equal to the square root of x. Now, square root of x is also considered as a power function because we can write square root as x to the power of 1/2. So that means to find the derivative of x to the power of 1/2, right? We follow the same thing, bring down the power, decrease the power by 1, right? So 1/2, bring it down, decrease the power by 1, right? So it's going to be x to the power of 1/2 minus 1, which is 1/2 times x to the power of negative 1/2. Right? So let's rewrite this in terms of radicals, right? So negative 1/2 in the exponent means it should be in the denominator, right? So we will have 1 over 2 times x to the power of 1/2. And 1/2 means square root, right? So this is just 1 over 2 times the square root of x. Okay, and that's how you take any derivative of any radical function, actually. So let's say I have g of x is the nth root of x. Okay, now nth root of x, I can write this as x to the power of 1 over n. And to find the derivative of that, right, we do the same thing. X to the power of 1 over n. We bring down the power, 1 over n, and then decrease the power by 1, right? So 1 over n minus 1, which will be 1 over n times x to the power of 1 minus n over n, right? Whatever that is. But usually that is a negative number. Okay? Right? That's usually a negative number. All right. Now, there are many different examples and practices that we will take a look at. So the first one we're going to have is, what if we have a power function with negative integers, right? Let's say I want to take the derivative of x to the power of -6, right? And we follow the same thing, right? We follow the same power rule. Bring down the power, right? Put it here, -6, and then decrease the power by 1, okay? X to the power of -6 minus 1, right? What more do we have? We have -6 times x to the power of -7. Right? So it's the same idea, right? As long as you have a power on x, you just bring it down, decrease the power by 1. Doesn't matter if it's positive or negative or fraction or decimals, right? We follow the same rule. Okay. Now here's another one, d dx of 1 over x. Now, if you want to give that a try, go ahead and pause the video and try it out. Okay. So to do this, we have to first rewrite it in the form of a power function, right? X to some power. Now, 1 over x is actually x to the power of -1, right? And that way we can clearly see what the power is when we want to take the derivative of it, right? Bring down the power, decrease the power by 1. We get -1 times x to the power of -2, which is -1 over x squared. Okay. All right. And let's try another one, d dx. You know what? I'm kind of used to x. That's 2t, right? d dt of 6 over t to the third power, right? And just a quick reminder, this t in the denominator just tells us what our independent variable is. or when are we taking the variable with respect to, all right, with respect to t. All right, let's go ahead and do this. First, same thing, right? We're going to bring up the t so that we have power function, right? 6 times t to the negative third power. Now, the constant 6 we can bring on the outside of the derivative of t to the negative third power. All right, and then that will be 6 times negative 3 times t to the power of, so negative 3 minus 1, that will be negative 4. All right, so clean this up. We have negative 18 over t to the fourth power. Okay, and again, very straightforward. When you have anything of power function notation, you just bring down the power and decrease the power by 1. All right, and lastly, here is the general function rule. If n is any real number, then the derivative of x to the power of n is just bring down the power by 1, and then bring down the power and decrease the power by 1. All right, so our last example, let's go ahead and work on a really popular type of questions that you will see. Find the equation of the tangent line and normal line to the curve. Okay, so equation of the tangent line is pretty easy to find, right? And the normal line is the line that is perpendicular to the tangent line through the point 1 and 1/2. So we'll talk about the normal line in a second. Right, so let's focus on the tangent line. Okay? So for the slope of tangent line, we need to find out what dy dx is when x is equal to 1, right? Because we want it to be at that point, the tangent line at this point. Okay? So let's go ahead and find the derivative of this function. Right? So dy dx is equal to the derivative of square root of x over 1 plus x squared. All right, so that's in the quotient. So keep in mind, we have to do the quotient rule. Let's say the numerator is u, and then denominator is v. Right? So we have u is the square root of x, v is 1 plus x squared. Okay, and we need the quotient rule, and let's write down the quotient rule on the side here. U over v prime is, start with the denominator, v squared, copy the v times u prime, minus, put the prime on the other one, so v prime times u. Okay, so let's go ahead and find u prime and v prime. So u prime, that's going to be the derivative of a square root of x, which is the derivative of x to the power of 1/2, and that is 1/2 times x to the power of negative 1/2, right? Or 1 over 2 times x to the power of 1/2, or 1 over 2 square root of x. Okay, and we'll see which one we want to use later. All right, v prime is going to be the derivative of 1 plus x squared, right? So derivative of 1 is 0, derivative of x squared is 2x, right, which is 2x. Okay, so basically what we have here is u, v, this is u prime, and this is v prime. All right, so let's go ahead and do that. Applying the quotient rule, in the denominator we have v squared, right? So that's 1 plus x squared quantity squared. In the numerator we have v times u prime. So v is 1 plus x squared times u prime. That's 1 over 2 times radical x, minus v prime, that's 2x, times u, which is square root of x. Okay. All right, so that's our derivative. Now, don't worry about cleaning it up. We're not going to worry about that because we are actually going to evaluate it at x equal to 1 to find out what the slope of the tangent line is, right? So dy dx, evaluating at x equal to 1, right? So that's equal to 1 plus 1 squared times 1 over 2 times square root of 1 minus 2 times 1 times the square root of 1 all over 1 plus 1 squared quantity squared. All right, so let's see what we have. We have 2 times 1/2 minus 2 times 1 all over 2 squared. All right, what is that? That's 1 minus 2 over 4, which is negative 1/4. Right, so negative 1/4 will be the slope of the tangent line. Tangent line at x equal to 1. All right, so next we need to find the equation, right? So we have the slope for the tangent line. Right? So tangent line at x equal to 1. We know that the slope is negative 1/4, and then we also have a point that's 1 and 1/2. Okay. Now from this point on, you can use point slope form or slope intercept form, right? So if you want to use point slope form, right, y minus 1/2 is equal to negative 1/4 times x minus 1. Right? And that will be y minus 1/2 is equal to negative 1/4 plus 1/4, and add the 1/2 to the right, we get y is equal to x, negative 1/4 x plus 1/4. Oh, sorry, plus 3/4. Okay, and that's the equation of the tangent line. Tangent line. And next, the question also asks us to find the normal line, right? And what's the normal line? The normal line to our curve C at point P is the line through P that is perpendicular to the tangent line, right? So we know that the tangent line is this. So for the normal line, it's going to be perpendicular to tangent. Right? That means the slope of a normal line times the slope of the tangent line is going to be negative 1, right? That's the property of perpendicular lines, right? When you multiply the slopes of two perpendicular lines, the result is always going to be negative 1. Right, so slope of the tangent line is negative 1/4, right? And that should be equal to negative 1, right? And that means the slope of the normal line will be multiply the negative 4 over, right? So we have positive 4. Okay. So the normal line also will go through the point P, right? Which is 1 and 1/2. Okay. So we're going to use the new slope for the normal line and the point on the curve 1 and 1/2 to find the equation of the normal line, which will be y minus 1/2 is equal to 4 times x minus 1, which is y minus 1/2 is equal to 4x minus 4, and we add the 1/2 to the right hand side. We have y is equal to 4x minus 7 over 2. Okay, and that's your the normal line of the curve at the point P. Okay, so 2.3, this is the basic introduction to the derivatives. And all these formulas are going to be very useful, and you will be using them for the rest of the class, and of course the rest of calculus, right? When you take Calc 2 and Calc 3, everything comes back to this section, right? A lot of the derivative formulas, derivative techniques will come into here. And let's do a quick recap. This is the basic derivative differentiation formulas that we talked about, right? Derivative of a constant is 0, power functions bring down the power, decrease the power by 1, and then we have a constant multiplier, adding or subtracting, and last but not least, the quotient, the product and the quotient rule. Okay, so it would be nice if you have like a sheet of these differentiation formulas when you're working on your homework, and it will save you some time. All right, thank you guys very much. That will be all for 2.3, and I'll see you next time.